Alright, this objective is GCO 5. We're looking at the worksheet number 3. Worksheet number 3 deals with translations. So let's first just look closely at notation here. This is called vector notation because our motion, our translation is defined in this little vector here. And it says 2 and negative 3. Now the 2 represents the x motion, so 2 to the right, and negative 3 means 3 down, so x comma y. So basically each point is going to move 2 to the right and 3 down. So everybody's going to move in this vector direction. All points will. Not only J will land there to be J prime. But K would go 1, 2 over, 1, 2, 3 down. Here's K. 1, 2 over, 1, 2, 3 down. Here's H. And just quickly we can put together our triangle. And we have our first translation. Now one thing I want to show you is that K moved in that same vector. And so did H, of course. Everything moves in that same vector direction. And you'll notice everything is parallel and everything lines up nicely. Let's do another one here. This one is just 6 comma 0. Actually, I'm not going to do this one, but let's talk about it. 6 comma 0 is the notation. That just means everything is going 6 to the right. Let's do this one. This one says the notation is negative 3, negative 1. So everybody is going to go 1, 2, 3, down 1. Here's where L prime would land, and maybe I'll just quickly draw that vector there. And so M would go over 1, 2, 3, down 1. Here's M prime. Everything N would go 1, 2, 3, down 1. This is N prime. And so we can connect our points that have all moved by that same vector. And we've translated our triangle to a new location. Okay? Now a couple things that happen with translations is there's different types of notations. There is something called coordinate notation. And there is something that's called vector notation. Now these are both the same thing, but just written in different ways. So let me show you what we mean by that. Here, the point A moved to A prime. And so it went from negative 4 to negative 1. So in other words, it increased by 3. In coordinate notation, we would add, say, that x plus 3. In other words, the x-coordinate added 3. In vector notation, we just put 3. Now let's look at what happened to the y-coordinate. We went from 1 to 3, so y increased by 2, and we would put a 2 here. So this is a shortened version. It represents x and y change. This is more of a rule to say take your x value, add 3, y value, add 2. Let's just do one more quickly. I went from a 7 in my pre-image to a 3, so I subtracted 4. And I went from a 1 to a 0, and I subtracted 1. So this is called coordinates, and this is vector, would just be negative 4, negative 1. Sometimes they will give you rules and ask you to apply them to solve for either the pre-image or the image. Let me just do 2 of these and show you how this works. So here's the coordinate rule. Take away 6 from the x, take away 1 from the y. So that would leave me at negative 7, and 1 is where I would land. Notice here I have the image been given to me, and I want to know what was the pre-image. So in this case, x was unchanged, so it must have been 8 to begin with. And we subtracted 4 from this number to get that number. So going backwards, I could add 4 to know what it originally was. To understand, I worked from the image to get my pre-image. The last thing I just speak to is something called a resultant vector. Translations are kind of cool because if you do a translation, say from here to here, and then you did a second translation over here to get a double prime, one thing you could do, you could get a resultant translation, meaning a sum of the two. This is the resultant one, and it would be basically a combination of this one added to this one.